Hello everyone, it's August 16th. Let's see what we're gonna have today. New 21 game. Alice plays following game, loosely based on a game of 21. Alice starts with 0 points and draws numbers while she has less than k points. During each draw, she gains an integer number of points randomly from the range 1 to max points, where max points is an integer. Each draw is independent, and the outcomes have equal probabilities. Alice stops drawing numbers when she gets k or more points. Return the probability that Alex has n or fewer points. The probability that Alice has n or fewer points. So wait, hold on. And draws number while she has less than k points. During each draw, she can draw from 1 to maximum. We want to know the probability that Alice has n or fewer points. So Alice can draw when she has less than k. Okay, k is the maximum Alice can have. So start with 0, so Alex can do one draw. And the draw is between 1 to 10 in the first one, right? So let's do one draw, or stop, and that draw will make it probability of smaller or equal to n. Here n is 6. So Alex can do one draw. They have 60% of the chance to get 1 to 6, and a 40% of chances larger. So each draw is from 1 to max points. Right, that's one draw. And then I have a k is the limit. So I can do one draw, the two draw, and I also have n. Now, if n must be bigger than k. Okay, n is bigger than k. So the question is, because I can keep drawing until I go above k, right? Until I go above k, then that's the end. Which means all the drawings before we reach k, it doesn't matter. What matters is the last one that go above k. So if, let's say, the last one I get is k minus 1. Okay? This is, I'm trying to say the max we can reach, and then plus max points. This is the maximum you can reach. So if this is smaller or equal to n, then the answer is 1. 100%. Which is exactly this situation. Right? So this is kind of the edge case. So if n is very big, right? So now normal case is, so other cases, right? Other cases less trivial is k minus 1 plus max points is larger than n, right? Which means this is the potentially largest And then what we want to find is the probability of the last one landing within. Ugh. Yeah, we have some points is smaller, some points will be bigger. Right, that is a probability. But that's based on k minus 1. Right, we're ending at k minus 1, then we have those. And then at k minus 2, we have something. K minus 3, we have something all the way to a point where when we add the max will not be bigger than k. Yeah, we add a max to become k minus 1, right? So we want to consider is can we do, let's say, the probability of having k minus 1? Because once I know the probability of k minus 1, then I know because you do one more step, right? You do one more step. will be multiplied by, plus this is larger than n, right? So basically we'll have n minus k minus 1 plus max points. Now this one minus n. So like this divided by max points. This is how much additional we can do. So yeah, this one times this will be the probability. Right, so we get a probability of k minus 1, and we do this. And that will be plus probability of k minus 2. The probability of k minus 2. So we can roll a 1, and then we'll add this. So, I mean, technically, it has to be larger than k. Yeah, it's k minus 2 all the way to a point where k minus something. Even you plus the maximum, it's still smaller than n. Now that is when that's it. But you can hit n, right? Yeah, it's fine. Yeah, it will be a point where you have to reach k. So only you add something that's larger or equal to k and smaller than n, only those will count. Larger than k. And smaller equal to n. Yeah. So you can find whatever this is until a point where it does not get larger than k. Right, it cannot reach larger or equal to k. And that's when we stop considering. Okay. So now how we compute this thing? Okay, the other, I think you just add them together. So this is the probability of having this point. So the probability to have a point, let's say 1 point, is 1 over maximum. Well, we get it by itself. right? And then plus P1 times, max point. Now P3 will be, you do it by itself, or you do it from P2, or you do it from P1, P2, and then you roll a 1, and then P1 you roll a 1, right? So the probability of getting a 4, you roll by itself, or you roll, you get a P3, and you do 1, or you get a P2, right? Or if it's a P2, and then say I can reach a P3, then it's already been covered. So it has a P2 and then do it directly, or you do a P1 and directly. So essentially you can take these out, right? Okay, and then P5 will be the same. Until you reach P max points, right? Because below P max points, you can always do the same thing. So we can say P PA, okay, so A will be this 1 plus PA minus 1, PA minus 2, P1, right? That's PA. That's when it's smaller than the max points. Now beyond the max point, right? So beyond max point, how about n plus 1? Well, we can never do a 1 over m because that's not possible. So I roll a P1 first. Right? We roll a P1. And then we have PM. We need to now find a PM. So it'll be PM. Or we roll a P2. Then PM minus 2. Or we roll a P3. Then actually minus 1 and minus 2. Alright, so we roll this all the way. P maximum. Oh, isn't that the same? Yeah, I think it's the same. So yeah, we don't repeat. So that's PM plus 1. And plus 2 is the same thing. How is this gonna work? I don't know. Okay, like DPI will probably have exactly I points at some point, which is add them together, yes. The base case Coming. Okay. But isn't this solution in a timeout? Yeah, it's in a timeout. But I think we can optimize it. So basically this says to find Pj, right? What we need to find is, because each round it can do j minus 1, pj minus 1 times 1 to m, pj minus 2 times p. So this is to take 1, take p minus maximum. Right? And then of course you don't really get to maximum, you get to whenever it becomes 0. Right, whenever it becomes 0. So which is, for j is over 1 all the way to max. Yeah, but they don't get to max. You get to wherever this is large equal to 0. Oh yeah, and I minus j has to be smaller than k. Right? I minus as a pi. Yeah, it's like a sliding window. This is like a window. Just the window gets bigger and bigger. Yeah, so let's say we have this one, that's already done. I'm going to find this one, pi. Right, so it's just a window. Minus 1 all the way to minus max. And okay, so we can handle this part. How about when we hit K? We cannot hit K. Right, we cannot hit K. Which means on the sliding window on the front, so we want to keep adding, but if it's K, then we just stop adding and then we just reduce. So it's like a DP with sliding window. So what do I say here? What's the current? We add I minus 1. We always add I minus 1. And check. Okay, so I say current always plus equal to, and then we check if we have reached beyond max points. So I minus max points is large or equal to 0. That's fine. So we have I minus 1 minus the max equal to max minus max points, because you can minus max points, right? You can minus max points. It's all allowed. So if it's equal to 0, then you still don't remove. But if it's larger than 0, then you need to remove. So I say if it's larger than 0, then current minus equal to dp minus max points minus 1. Because those can remove, right? But minus 1, that is extra, so you need to remove it. So we'll make sure we only have the size of max points. So current will minus the last. And here we also need to check if I minus 1, this is newly added, need to be smaller than k. Right? Because if it's bigger than k, bigger or equal to k, then that one we will never reach. It can never contribute. So this must be smaller than if it's smaller, then we always add it. And then once we add it, we also check that. So once it's done, we say current is just a sliding window, right? This is a sliding window. Then we say dpi shall equal to current times 1.0 divided by max points. And the rest will plus equal to dpi. Okay, let's give this a shot. Oopsie doozy. That is very bad. Oh, that's not all of them. My bad. Yeah, I realize. It has to be larger than k. Huh. Oh, you're equal to k. Try it. N equal to 0, k equal to 0, max point is 1. I think I can do it this way. Because I decide whether 0 should be included. So we say, is 0 larger or equal to k? If it is, then we do dp0. If it's not, then we do 0.0. K is equal to 0. So rest is already equal to 1. How? It's plus equal to. How did it become 0.5? I don't understand. It starts with 1. How is the output become 0.5? I honestly have no clue. Like, what? How? What the hell? What? I mean, how? I know. This become negative. Holy crap. Because we never add anything, so we should not have removed anything. Okay. So basically, so when it's larger than 0, I minus max points is larger than 0, and it has to be. It's the K. It's the K is the issue. The K is the issue. This says if we reach K, then we don't include. So it has to be larger than 0, and this has to be, and I minus max points minus 1 must be smaller than K. Right, it has to be larger than 0, it has to be smaller than K in order for you to remove. Otherwise, if this itself is larger or equal to K, then that point cannot be removed because you never added in the first place. Okay, oof, this is a little bit rough around the edges. Yeah, okay. Now let's get back to the previous test case. Let's throw them in again. Okay, let's try this one. There we go. That's the one. Oh, I say it's pretty hard. Actually, it's not. The DP, I don't know what happened to me. I honestly don't know what happened to me. Like the first crack is just, I'm not able to get it. Alright, I'm not able to get it. The first crack. I mean, it's pretty obvious it's DP. And once I realize it's DP, immediately I know it's a sliding window. So it's not really a hard problem. But for whatever reason, I don't know, I just couldn't get the DP part ready. And now I'm also curious if this is going to make things faster, which I'm going to try, which means I don't do it this. I saved 1. So return try the editorial method, editorial way of using accumulate. Save some cycles of if statement. It's just this one is larger equal to 0 and the smaller than k. That's it. Let's see. Oh, this is much faster. Holy crap. Should immediately get to 0 milliseconds. But it's very, very unfortunate. Yep, that's exactly right. Yep, that's exactly right. So, yeah, I don't know. It just, the initial crack was just not available to me. And that's happened this for like